Okay guys, welcome to Inequalities and Inequations. Now, this topic sounds really complicated. Don't worry, it's actually probably one of the most straightforward things with equations. Inequalities and inequations. Now, an inequation is just an expression that contains an inequality sign. Okay, so inequation, you might notice, guys, sounds like equation, just with the word in at the start. The reason why we call it is an inequation, not an equation, is that it has an inequality sign. So remember equations, when we were talking about them back at the very start, we said an equation is anything that involves an equal sign, equation, equal sign. See how they kind of sound similar? Well, an inequation is anything that involves an inequality sign. These are the inequality signs, guys. I'm probably pretty sure you're used to seeing them. Less than or equal to, greater than or equal to. Be writing this down, guys. So first off, you need a heading in your book, Inequalities and Inequations, and you need to write down anything on this page. Also, if anything I'm saying you think is relevant, it's not written on the page, write that down as well. So, less than, which is this guy here, less than or equal to, greater than or equal to. Pretty straightforward. Just like equations. So we've been looking at proving equations, finding if they're true or if they're false with substitution. Just like equations, inequations can either be true or false. For example, you could have 8 is greater than 6. This is an inequation. Why is it an inequation? If you look here, it involves an inequality sign. It involves the greater than sign. So we have 8 is greater than 6, and it's true, because 8 is greater than 6. Or we have 5 is less than 3. Okay, this is false, because 5 isn't less than 3. It's pretty simple. Those ones kind of straightforward. But what happens if we have an inequation that says x is greater than 2? Okay, what could x be? This sentence could be either true or false, but we don't know because we don't know what the value of x is. There are many different values of x which will make the sentence true. Say, for example, if x equaled 3, that'd be correct. Or if x equaled 200, that'd also be correct. Okay? There's many different possibilities. But the problem is, guys, we can't possibly list all of the solutions to the inequation x is greater than 2. But what we can do is show them using a number line. So if we get given the inequation here, x is greater than 2, we can use a number line, which I'm hoping you guys have seen before, pretty sure you've done that in Year 7 and Year 8, in order to demonstrate this concept, or in order to show somehow this concept without listing all the different possibilities. So this is our number line. You'll notice carefully the spacing. We have spacing in between these, guys. Between 2 and 3, between 3 and 4. As we go to the right, our numbers increase. As we go to the left, our numbers decrease. Okay? The lines, you'll notice, at the end, the arrows here. We have an arrow here and an arrow here. They tell us that the line keeps on continuing. Okay? They make an assumption that the line keeps on continuing. So like I said, as we move to the right, the numbers increase. As we move to the left, they decrease. We can show an inequation on a number line in many different ways. Okay? I'm going to show you 2 examples on the next page. So, example 1. X is greater than 2. Okay. What we need to do first off is locate 2 on our number line. So as you can see here in the diagram, that's what I've done. Guys, I haven't drawn this because my stylus is really messy. I've actually just done this in another program and put these in here. You'll notice the circle I've drawn above the 2 is hollow. That hollow circle represents we're starting at the 2, but it's not equal to the 2. Okay? And then we've drawn a line up our number plane, and we've had the arrow and continuing. We've drawn an arrow again here, guys, at the end. Now, that arrow tells us that the line keeps on going forever in one direction. And the last thing, the final last thing we need to do is this label at the bottom. X is greater than 2. That label completes our solution. So 3 things. Hollow circle for when it's either less than or greater than. Okay. Arrow to show it's keeping on continuing. And solution. Guys, you need to be writing this down. You don't have to draw my annotations, but maybe writing a 1, 2, 3 for the first example so you can tell the 3 things you need to write down. Now, other inequation at the bottom of the page here, this guy here. Okay, we have x is greater than or equal to. That's our little inequality sign there, greater than or equal to 2. When we're drawing this on a number plane, it's a little bit different. You can see here now my circle is coloured in. That means that this inequality is inclusive of the 2, because I'm saying greater than or equal to. Okay, whenever it's greater than or equal to or less than or equal to, at your starting point you draw a coloured in circle. Okay, that's because we need to include the value of 2. Again, same thing, arrow to the end and writing that underneath. That's as tricky as it is, guys. It's pretty straightforward with those, okay? So that's showing inequalities, showing inequations on a number line. The next part of inequalities and inequations, guys, is solving them. Okay, so you need to be writing this underneath those examples you've just drawn. Like an inequation can be solved by doing the same thing to both sides. We have spent the whole unit solving equations. What you do to one side, you do the same to the other side. Okay, and equations is any two number sentences with an equal sign in between. Okay, an inequation is two number sentences with an inequality sign in between. It's pretty much the same thing, just the sign slightly different. But inequations, like equations, can be solved by doing the same thing you do for one side to the other. Okay. This is a little note that you have to make, however. You might want to do this in a box, you might want to underline it, you might want to do it in red pen, because this is something we haven't done with equations. If multiplying or dividing by a negative number, okay, if we get to the end and we need to multiply or divide by a negative number, we reverse the inequality sign to keep the inequation true. Okay, I will show you an example in a minute of how that actually works. Okay, just remember that rule. If at the end you're multiplying or dividing by a negative number, we reverse the inequality sign to keep the inequation true. Also, please find my hilarious cat dressed as a lobster picture. I thought it was great. So, our example here, our first example of an inequation that we need to solve is 2x is less than 4. 2x is less than 4. So, what we do to one side, we do to the other. Again, step 1, write our inequation down. 2x less than 4. That's step 1. Okay, what we do to one side, we do to the other. I'm trying to get x by itself, yeah? Trying to find the pronumeral. So, 2x less than 4. I've got 2 of x's, I need to find 1x. What do? Multiply it by 2. Multiply by 2. Sorry, divided by 2, guys. Sorry, Mr. Corsi's lost the plot a bit. So, it's multiplied there. I've got 2x is less than 4. I need to find what 1x is. So, what I do to one side, I do the same to the other side. I make the subject x by itself by dividing both sides by 2. So, those two cancel out. So, it becomes x is less than 4 divided by 2, 2. That's it solved. Okay, that's it. That's in its most simplest form. Okay, 2x is less than 4, which means that x is less than 2. Very straightforward. Here's the really tricky example. So, first thing we need to do is we need to write down the inequation. Okay, I've got it there. I'm going to write it down again for you guys. 1 minus 2x divided by 7 is greater than minus 1. Okay, again, you probably recognise this. If I didn't have the inequality sign, if I had an equal sign, this is something that you guys have been doing a lot of. Okay, so first thing I need to do, I'm trying to get the x by itself. Okay, whenever I have a division, it's saying this whole thing on the numerator divided by the denominator. So the first thing I need to do is I need to multiply both sides by 7. Okay, so first thing, multiply this side by 7. I'll do this in red pen so it's clear. Multiplied by 7, multiplied by 7. So when we multiply the left-hand side, this cancels this out. Divided by 7, multiplied by 7 cancels each other out. So our inequation becomes 1 minus 2x is greater than minus 7 multiplied by 7, minus 7. There you go. So, next thing we have to do is we have to get this 1 away, okay? Because this 1 is in the way of our x. So, we have to, 1 is currently a positive number. So, we have to subtract 1 from each side. I have to subtract 1 from here. subtract 1 from there. Sorry, I'll write that in red pen for you guys so that's a little bit clearer. Subtract 1 from here, subtract 1, I'm just going to write it at the top, from there. 1 minus 1 cancelled each other out. So it becomes minus 2x is greater than, sorry, that's a bit of a dodgy greater than sign. Anyway, you get the point. Is minus 7 minus 1 becomes minus 8. Okay, now we have minus 2x is greater than minus 8. Remember that rule that we said, guys. We said that whenever we are dividing or multiplying by a negative number, we need to switch our signs around. So step 4, that's step 1, step 2, step 3, and now step 4, we need to divide by negative 2. Divide by negative 2. But what we also need to do is we need to flip around our sign. We need to flip our sign this way. So, negative 2 divided by negative 2 cancels each other out. Okay? Negative cancels, negative cancels. 8 divided by 2. X is less than or equal to 4. I'll show you that one again, guys. Step 1, write our inequation out. Step 2, multiply by 7. Step 3, minus 1. Step 4 is dividing by negative 2, but the main thing when we divide by a negative or multiply by a negative number is we flip our inequation sign around. We flip it around. So then our answer, our solved answer, comes to a total of x is less than 4. And it's as straightforward as that, guys. Those two examples will help you complete all of the exercises you need.